For the conservation and management of animals and their natural habitats, the use of radio telemetry tracking is a common and reliable method. E4E's Radio Telemetry Tracking project started in 2013 as a collaboration with the San Diego Zoo's Wildlife Alliance. Because traditional methods of tracking animals on foot are time-consuming and physically taxing, the radio telemetry tracking team worked to produce a drone-based system that was intuitive and user-friendly. This project has had deployments on the island of Little Cayman and Big Ambergris Cay in the Turks and Caicos Islands. This summer, we have collaborated with Dr. Matthew Gifford at the University of Central Arkansas, who wants to track common collared lizards. They want to track common collared lizards in a fixed area and produce results every 10 minutes. And because they want results so frequently, having a drone fly every 10 minutes is not a viable option due to time constraints and battery limitations. Our current proposed solution is to develop a system of stationary towers to track the lizards, as this would allow for a more long-term setup. One method proposed to implement in our system is a time difference of arrival, or TDOA technique. With TDOA, we have a transmitter broadcasting a signal and multiple receivers picking up that same signal. Because we know that electromagnetic waves travel at about the speed of light, we can use the differences in time between when each receiver picks up the same signal to estimate where the transmitter is located. One of our largest challenges with TDOA is timing synchronization. This is because before we can compare timing between received signals, we must first ensure that our systems are properly synchronized, otherwise our results will be skewed. In order to find the time delay between the systems, we can use one of the receivers as a beacon and have it send a pulse to the other receivers. We can then later align the signals with that received pulse to be able to properly time signals received from the transmitters. Spatial accuracy using TDOA can be approximated using the equation distance equals speed of light times time synchronization error. Our system uses a sampling rate of about 2 MHz, and because of this, without subsample synchronization, we can only achieve a spatial accuracy of 150 meters. Using binary search technique, we are able to achieve subsample accuracy between 2 identical time offset signals, which would theoretically allow for less than 1 meter accuracy. However, in reality, noise and differences in signal strength are certain factors that must be dealt with, so moving forward, our team will work towards a more robust synchronization solution. In the future, we have several collaborations and deployments planned. Along with tracking common collared lizards in Arkansas, we plan on collaborating with Gus Calderon at Airspace Consulting and the LA Zoo to track pandas with the drone-based system in Chengdu, China. There is also opportunity to track iguanas in the Turks and Caicos Islands during summer of 2022, which will also be a drone-based system.